Dear students, we are going to see another tough and hard problem, very hard problem. See, it's a hard spot problem. In mainly we discussed in trigonometry, these are all hard spot problems. Why do we identify this problem as a hard spot problem? Means it is a polynomial type. See the polynomial type, summation. At once you see this kind of polynomial type, you see that it is much difficulty, but it's not much difficulty. It is such a easiest one by way of utilizing this formula identity as 1 by 1 minus x, that is 1 plus x square plus x cube plus and so on up to infinity. This formula, this algebraical formula, how it is going to be applied in trigonometry by usage of polynomial function, we make it as simple and easy. Now let us see. See, the problem is if 0 less than theta less than pi by 2, the angle is between 0 to pi by 2, that means it is understood it is in the first quadrant. It is in the first quadrant, x, y and z, given some polynomial functions. What is that polynomial? Cos power 2n theta. By seeing this, you may finding it so difficult that everybody knows. But by way of doing this problem, how it is so simplified? Let's see. X is equal to summation 0 to infinity cos power 2n theta. This is the polynomial. You know what is a polynomial? Polynomial is nothing but summation of an x power n equal to p of x. That you have learnt in 7th or 6th. But we are going to see the same thing in trigonometrical approach in terms of cos sign. How it is cos power 2n theta. That is 0 to infinity means we are going to apply n value by way of 0. Put 0 first term. What will happen? Cos power 0 theta. Then n is equal to 1. So this is summation means what? Each one after that plus plus plus. So that means cos power 1 2 into 1, that is theta. Remember that 2 into 1 cos power 2 into 2 theta. Likewise it keep going. So that means it is nothing but 1. Cos power 0 is nothing but 1 cos square theta plus cos power 4 theta and so on. This problem is how it is going to be applied here. Instead of x, you remember that it is cos square. Instead of x, it is nothing but what is that? Cos square. This identity is most helpful for doing this particular problem. This is the algebraical identity. That is nothing but 1 by, instead of x, we are going to use cos square. That is 1 minus cos square theta. Remember that this 1 plus cos square theta, cos cube theta, that is x means cos square. X square means it is nothing but cos power 4 theta. Next term would be cos power 6 theta according to this problem. Here also it keep going like this. So that means 1 minus cos square theta, trigonometrical identities. Trigonometrical identities, you know, it is nothing but 1 minus cos square theta equal to sin square theta. This formula you know very well. Even the previous exercise, previous sum also we have applied, and here it is nothing but sin square theta. So this entire term becomes 1 by sin square theta, which is nothing but x. So this term become x. Likewise, this also we are going to do. The same scenario, we are going to apply the same thing, which is likely to be like that. It is 1 minus that formula. When you apply here, this will become 1 by cos square theta. Is it clear to you? Is it not? So very simple. X is equal to 1 by sin square theta. Same way 1 by 1 minus. Here what we got? X is equal to 1 by 1 minus cos square theta. The same formula I am applying for this term for y. It is 1 by 1 minus sine square theta become cos square theta. Now x is like this. We will take it as a, and this is nothing but b, that is y, and z like this, the other term. Here cos power 2n theta, sin power 2n theta. That means two terms going to exist. Two terms are exist. That is 1 minus cos square theta sin square theta. Previous terms are not like that. Only one term exists. We got one result. Now it is two terms. So I have written 2 now. That is cos square theta and then sin square theta. Now that term, how it will be going? It is 1 by 1 minus cos square theta sin square theta. That is for z. This is, you take it as result C. Now result A gives 1 by sin square theta for x, 1 by cos square theta for y, and 1 by 1 minus cos square theta sin square theta for z. What we want to prove? Product of x, y, z is equal to summation of all these variables x, y and z. That is x plus y plus z is equal to x, y, z. This is what we want to prove. So let us take a left hand side. X, y, z is equal to, x is equal to 1 by, what we had here, 1 by sin square theta. And what is y? It is 1 by cos square theta. And what we had here, 1 by 1 minus cos square theta sin square theta. So this is the result exists for this. This you take it as a star. Now this is left hand side. Let us take right hand side here. The same result if we obtain, that means the result is over. The problem is solved. So now let us take the result of x, y, z by summing up. By summing up all the three results, that is a plus b plus c, all the three results I am going to take now. That is 1 by sin square theta, that is for x, and for y 1 by, it is cos square theta, and plus 1 by z cos square theta sin square theta. See, here you have to very carefully see. Previous one was simple multiplication and we obtained the result, let it be. Now you have to carefully and conscientize way you have to see this result by way of taking this sin square theta and cos square theta. Taking LCM for these two only, not here. Only for the first two case. And when you take here, this will go up and this will be going this side. So cos square theta plus sin square theta plus this is as it is. Let it be. Now this cos square theta plus sin square theta is 1 by sin square theta cos square theta. This is the identity of previous one. 1 minus cos square theta is sin square theta. Sin square theta plus cos square theta is the identity which you know very well. So that we applied here. That is 1 by sin square theta cos square theta plus this result 1 minus cos square theta sin square theta. So again you have to take LCM for these two. First we have simplified first two. Now you take the other two. Now by way of taking the simplified result here, that is this is 1 by a, 1 by c. So by doing this sin square theta cos square theta into 1 minus cos square theta sin square theta, and this you are going to take here and this term will be this side. So by doing this sin square theta cos square theta on this part, and here it is 1 minus cos square theta sin square theta. Now these are two similar terms with different signs, SIGNS signs. Remember that these two are getting cancelled. So by doing so we get the result of 1 by sin square theta cos square theta into 1 minus cos square theta into sin square theta. This we got as double star. See that this is x plus y plus z. So x, y, z we have this result, and by way of summing up we have the same kind of result which we arrived for the resultant of this. So by star and double star we have proved the result. By star and double star we have proved the result. Once again I come back to the problem of how we solve the problem. First we have taken the polynomial function, and we have taken the polynomial function by applying trigonometric algebraical identities. So we have obtained the result of 1 minus cos squared theta, that by way of taking trigonometrical identities we simplified as sin squared theta and summing up all the result, and we got this result. And the same way for y also, because it is in terms of sine, so we got other result. By summing up, we are multiplying these three results, we got the first result as star, and by summing up this we got the second result. By taking star and double star, what we want to prove we have arrived. Is it clear to you? Is it very clear? I think so. You are very clear, because you are applying two things. One is trigonometrical identities, second one is algebraical identities. Algebraical identities play a vital role here by applying this, and trigonometrical identities here and there we have applied, and finally we got the result. Is it clear? No? Okay, good. Thank you.